Thank you very much. As I already said, I'm trying my very best to entertain you. It's not as gloomy as the previous presentation. But still about an exciting moment in a developer's life, like it was an exciting moment for me for now. Now it's like 1 year ago when I thought, okay, this code that helps me so much is really gonna benefit the community now, and I publish it to NPM. And I don't know, who of you has ever published something to NPM? That's less than I thought, because like I checked, there's 500,000 libraries out there. They must come from somewhere, and I don't think it's the same 10 people, but still. So even if you didn't publish there, you have this great library, and you can certainly imagine how it feels like you typing away the ideas flowing into code. And just before we continue, just a short stop, as we were at JSConf. If you're not sure if your library is great, there actually is another talk that tells you if it is. And I really advise you to check it out by Maggie Pint at JSConf. So the question I'm going to talk about is, if you wrote your library, did you actually wonder who might be using your library? Surely you got your target audience, like Node developers maybe, but like as this NPM works, anyone can install your library and abuse it for anything. And while if you're a nice person, you might consider, okay, maybe I take this into account. And so what kind of users are there out? Of course, Node server developers, but also people could think, oh, I could write a command line utility with your app. It's still kind of a Node application, but they got some different needs, because like on the server, your program is running like for ages. So, well, the best thing is it doesn't crash. The command line utility is meant to be launched like often and quickly, and if the user needs to wait like 10 seconds until you just did whatever your thing does, he's probably not that happy. And of course, there are front-end developers more and more using the Node package manager, why ever they're doing this. So the question is it possible to make a library work for everyone? And to answer this is, of course, what do these users probably want? I already talked a little about this. So the Node server developer, well, what can a Node server developer want? They put their Node modules folder out on the server and execute their code. So, well, best thing is you don't put all your trash can in the Node modules. Like, if you don't know what I'm talking about, there's this thing with Guy Fieri in the Babel code base, which is a true story. I'm going to talk about this in the end. It's just a simple line that apparently no one knows about. And the command line utility creator probably wants that their code is parsed as quickly as possible. And the front-end developers, they have weird, crazy setups like Webpack and who knows what. And in contrast to the other developers, they really have no control where their code runs. So when they get a library, the best thing they can hope for is that it kind of runs everywhere. So you have to account for that. And well, there's a new thing they want, and that is statically analyzable ES6 exports. So statically analyzable sounds exciting, but apparently, why would anyone want that? And by the way, what is that even? So there's this new JavaScript module system. And to understand why front-end developers might be interested in you providing exports in ES6, it's good to just look at what this offers, because people put some thought into this module system. So on the left side, this is what you would do in Node.js. Like when I export something, I attach it to the exports object, and yeah, then anyone can do anything with this exports object, and it kind of gets exported. In ES6, I can actually export named entities directly out of the code, like export some x, which has the value of foo. And importing is the same thing. I kind of require the whole library on the left side, and then I plug the x. Whereas the ES6 import allows me to just get this one entity x back. And there are also some restrictions, like require can be used anywhere in your code, and import and export are restricted to the top level. And you are not allowed to just, I don't know, concatenate strings when you're importing things. So what does this give us? Well, if you're a module bundler, like a module bundler application, then you can do two things. First of all, you see what libraries are not imported, because, well, people can not do string concatenation or anything, or just build the name of what they ever requiring here. And the second thing is, you can even go one step further. You can go into the module and just say, okay, this export is never imported and that export is never imported, so you can remove the code. And this is something called tree shaking, which I'm going to talk about in a second, which got some attention, but if anyone has ever tried that, I'm pretty sure it did not really work for you. And I'll tell you why that is, and actually it's the library developer's fault. So the right question is, of course, if I do this and change my library to use ES6, but this will break the library for everyone else. And the answer is, yes, of course it does. So how do you do it? Well, it's actually quite simple. So when you got your package.json file, you have this main field, and the main field said, okay, if anyone requires this library, give them dist/index.js. And what the bundler developers agreed upon is just add a second line. It's called module, and you give them a different export, which is an ES6 version. And if you provide this module field, then you expect the person importing it to know what to do with it. The extension I chose, by the way, is MJS, and like in the far future, people say it's a year, but who knows if this will ever happen. Node might actually support ES6 modules, and then that's how they're going to do it with the MJS extension. Yet still, okay, this is automatically recognized by the major ES6 bundle. This is basically Webpack and Rollup, and I didn't check the other one because they're not major. And yeah, well, so okay, that's how you do it. But then, of course, I have to write two libraries, one for the one users and one for the other users. And this seems like a lot of pain. But fear not, of course, I wouldn't be talking here. There's an easy way out. You just write the ES6 version, and then there is this handy tool I'm going to talk about, which is rollup. So what is rollup? Rollup is obviously a module bundler. It takes a bunch of ES6 files and creates a single file out of those. So this already gives you an advantage, because like if you have an application spread out over 100 little files, then what does Node do? It reads the first file, finds two require statements. Okay, so then I load those two files. Then again, I find some require statements. Then I can start loading the next file, and so on. And if I write a command line utility, this happens each time I run the utility. And obviously, you can look at the screen and wait for something to happen. If it's a single file, then you can have one file access, one path process, which is a little longer because the file is bigger, and that's that. But you can also create various formats. So it is actually a two-step process. The first process is like parsing the file, creating some abstract syntax tree, and so on. And then you can create an ES6 bundle, a CommonJS bundle, or some older formats that apparently people use or not. And it got two features which actually set it apart. One is the tree shaking I was already talking about. And the other one is something called scope hoisting, which is actually a rollup. I think it's the only one to support this, which you'll see in a second what it does. So the setup is actually quite simple. There's two ways of using it. There's the command line way, which is really boring, or the programmatic way, which is also very easy and not too different. So you just write a JavaScript file. I called it build.js. Then, of course, you have to use require, because rollup is not reading this file, but Node is reading the file. And then it has a method called rollup. You just supply the entry file, and this returns a promise when it's finished. And the promise resolves to a bundle file, which has a write method, and then you can just write a CommonJS model. And basically, that's all there is to it. The nice thing about the programmatic way is, of course, you can just write two files from the same bundle, and that's that. And so I got the two files I just set in my package.json over here. So got these. I wanted these two files and just these few lines of code. And then I just type node build.js, and I'm finished. got 2 exports for anyone to use. Everyone's happy. Well, just take a look at it. So here obviously I prepared everything because I'm not so confident in my typing skills. So this is a small project. Here you got my build.js file, did something really useful. So this I just only got one dependency, which is rollup, and I'm wrote a cool utility to convert first letters to uppercase. And basically this is the index file. It contains one function which first checks if I entered something that has a length greater than 0, and if so, it calls another function. Otherwise, it just returns whatever it got. And the other function is here. This is the middle one, actually. So in this calls again the function over here, which uppercases any letter and uses some string slice. Well, something that probably no one has ever written a library for. So what do? So I run this node build.js, and then when it updates here, you see the dist folder appeared over here. And here they are, my 2 files. So just let's look into this file. And well, doesn't look too different from before, except if I compare, okay, the make last letter uppercase has magically disappeared. Instead, we have this make upper, which comes from here. But the truly amazing thing is that you don't see like there were like 2 modules bundled together. It's just one big file, everything hoisted into the top scope, which is basically the main feature of rollup. So if in case there would be name conflicts, then rollup would start renaming variables, which is not a very complicated algorithm it uses, but it works. And apparently this optimization already provides a lot of benefits. So the latest library that switched to rollup was actually React. And they said that switching to rollup made their minified bundle 10% smaller and 10% faster. Just the switch, because there's no glue code necessary. And also, a lot of dead code could possibly vanish. So going one step further, of course, as I said, maybe someone has already written such a library. So maybe like someone like Lodash might already have solved this problem. So I'm gonna do a small modification here. I'd say I'm importing whatever it's called from Lodash. I think it's something, yeah, this one. And I'm replacing this, and basically it should still work. Oh, no, sorry, that's just something that was still in my... Oh, okay. So I'm getting an error message here. I don't know if you can read this. Lodash is imported, but could not be resolved, treating it as an external dependency. So apparently there's still one step necessary. And the reason why this happens is that rollup thinks you probably want to bundle everything together. But then again, rollup doesn't look into a node modules folder. So this is kind of an ambiguity. So here it decides it's external. To make this disappear, I just have to add a small line here. So next to the entry, I'm adding an external array, and I'm saying Lodash is external. And if I build again, it's quiet. Okay? But apparently this doesn't change anything for the output. And here it's become actually quite smaller. So everything that was still there just got removed. I imported here from Lodash. Actually, we didn't look into the other bundle yet, so let's take a look here. So there's a little more here. Apparently now it's using a require call here. So that's actually what we would do here. And it added an use strict because when you use E6 modules, it's implied that there is a use strict here. You don't have to write it, but outside E6 modules, it needs to be added. And then it does this thing, define property exports ES module. This is just a hint for module bundles. If they use the traditional import, this tells them if there is a default export or not, because this is a big difference between ES6 modules and Node.js modules. Like there's this default and the named exports, and that's actually a difference. So that's what it's all about. But then again, of course, okay, if I do this, now I have Lodash in my dependency. So everyone installing this needs to install Lodash, like implicitly. And like if you check Lodash, it's supposed to be here, no? Well, it's kind of biggish. So that's what everyone is installing each time they are installing my library, which is not too nice. So I might think, okay, maybe I can just plug this tool out of Lodash into my library. After all, I got all this tree shaking. So I got a different setup here. So now I didn't put it into dependencies, but only into the dev dependencies. But because of course I needed to build my bundle. And I used Lodash.js, which is a special ES6 build of Lodash, which has the proper exports. Otherwise, it wouldn't work anyways. And you can check it is an ES6 port. And I need this rollup plugin node resolve, which tells basically rollup, you may look in my node modules folder and bundle everything you find there, except if I put it into the externals field. So then again, I go here and import it from this time Lodash.js again. Oops. Again, it's called up first. And oops. As you can see, I will do something with Docker in the meantime.
You should use it also.
Well, huh?
Use it also.
Oh, maybe I should use it. That makes a lot of sense. But still, you see, it takes a little longer now. And before we look into the dist folder, let's just do a small wrap up what you saw here. So external dependencies is really easy. You put them into dependencies and you just mark them as external. And I tell you, this is actually most of the time the way I would recommend to use it. This is like if they're using Lodash anyways for whatever, then they have the code sharing and all this stuff. But you can also go this other way. So you can bundle your dependencies. So you need this extra plugin, rollup plugin node resolve, and yeah, add the plugin to those plugins array. So this might be cool when you're using only little from a library, but so now let's look back here. No, this was this one. No, did I? No, it's this one actually. Sorry. Okay. Now let's take a look here. Okay, 17,000 lines. Something went wrong. Or at least that's not what we expect, that we got 17,000 lines of code. Maybe we should not bundle it. But the question is, what got wrong? And if anyone has tried tree shaking, that's exactly what usually happens. I did not find a single bigger library out there where it worked correctly. So the thing is, like, this is the only drama you're gonna get from me today when tree shaking goes wrong. The technical title might be side effects and initialization. And well, that's what it's all about. The simple reason is that if you execute code while you initialize your model, and this code has or could have side effects. Usually it doesn't have side effects. Most of the time it doesn't, but well, rollup doesn't know, and rollup is really conservative about this. Then it will stay there. So we could just try it out. So like if I go here and say, okay, I have a constant x with a value of, I don't know, 4, then of course, what did I put? No, of course I put it into the output. That was really stupid. Const x equals 4. Then, of course, it is removed. But let's say it's 4 concat 2. Should maybe run the script. Yeah. So why is it still there? Because this should just give me a 42. Well, of course, if I say 4.concat2, what I actually do is string.prototype.concat call with 4 as this object and then the 2 as the argument. And who knows who would have tampered with string.prototype.concat? at least it's not in the internal table of rollup that tells us this function is safe, and basically I can patch you this concat function to do the weirdest things. So the sad truth is basically any code you run during initialization, which is a little more complicated than this code, gets removed. By the way, this code is safe. If I write into the right file, of course. No, similar to this. But anything more, object.freeze. By the way, object.keys gets removed, but it's a little shady out there. So the thing is, okay, side effects, modifying a global variable, calling any global functions with a few exceptions, or even implicitly calling most global functions. So rule of thumb, just don't execute code. It's a better library pattern anyways. And it makes testing so much easier if you don't run code during initialization, because then you have to wonder how you ever gonna inject anything, or I don't know. So what we have now, going back to the beginning, I was talking about the front-end developers. They want those E6 exports, and we got the quickly parsed code. Code that runs everywhere. Okay, of course, the answer is clear. That's probably some Babel things, so I'm just going to show you. Of course, there's a plugin for that. You have to be a little careful when installing Babel. So you got the rollup plugin Babel, and, well, usually you supply a Babel RC file. You could also just supply it here inline. That's the beauty of the programmatic approach. You need some presets. Okay, the latest preset, sure, but you also need to tell the sub ES 2015 preset, which is responsible for translating import and export statements, to be disabled. Otherwise, there's no tree shaking to happen. So some caveats here. And, well, of course, got this. Oh, this one. Probably yes. So I got the setup here with the rollup plugin Babel, and if I now run my build script, no, there it is. Then you see, okay, the constants have been replaced by variable statements. There are no fancy arrow functions anymore. It's just plain functions. So this is good to go. This works on all browsers dating back to who knows when. And, well, there's some discussion in the community if you shouldn't supply an untranspiled version so that anyone can run Babel themselves. But I think the consensus is that most bigger projects do not transpile their node modules folder because it's just so big. Which gets us back to the last point I wanted to talk about, is the user stuff in the node modules folder. So, I mean, I got all the test files. It could possibly be that someone might want to run my tests once in a while, just from the node modules folder, just because they see how much I cared and how well this is tested, or maybe this is just a simple flag. So what I didn't know for a long time, and apparently most developers don't know, there's a simple switch called files, and you can tell them just, well, I don't want anything but the dist folder. And what you get is, of course, the package.js and the dist folder, and maybe your readme, and that's that. And all your test files are gone. So this simple thing makes many people happy. And wrapping everything up. So what I would hope that you do if you're writing libraries, or at least I hope that more people would do, is that you use ES6 modules. You create two bundles with rollup. You distribute them as the main and the module bundle. You try to avoid side effects if it's possible in any way. And you transpile to ES5 and you use the files property. So before I end this, just a few pointers, a few tools you might want to look at next. Because if you're developing alone, or if you're putting your library on open source, then there are other people who might work with you. And then you might want to automate a few things like linting and testing. So a cool tool is actually Husky that I would check out. It's basically a glorified Git hook manager, which enables you to automatically install Git hooks on any machine that runs the npm install command. With this tool, I would advise you to check out lint staged, which enables you to, again, run commands on all files you've staged for commit, like a test, a linter. So even if you're a big library, you're usually only committing a few files, and then it's quick to lint them if you only lint those few 2 files. And of course, semantic release, which is the power tool for making libraries. This basically enables you to just publish to NPM from your continuous integration environment. What you do is you stick to a certain commit format, which tells you, okay, this is a major, this is a new feature, this is a bug fix, or this is a breaking change. And then it parses those, it determines what the next version number should be, it sets the version number for you, it writes a changelog for you. And all you do is just push. So for me, I just push to GitHub and it does all these things for me. And of course, Greenkeeper, which checks if your dependencies have new version. This is a GitHub tool, basically. And then runs your test suite against the new dependency versions and tells you if anything fails. And with that, I've already come to a close. It's late at night. And thank you. And if you want to, I don't know, look at anything I told you today, the slides are actually online on GitHub. Okay.